All right, so for section 2.2, we're going to go over some of the basic parts of rational functions that we're going to need to know. And throughout this, I'm going to try to also sort of prepare you for the marble slides activity that you'll be doing after you finish watching this video. So the parent function for a rational equation is 1 over x, and we can see that here. It's the red graph that you see graphed right here. And the domain for this graph includes every value except for x. So from negative infinity up to 0 and 0 to infinity. Sorry, I said every value except for x. I meant every value except for 0. So you can see right here at x equals 0, you have a vertical asymptote. So that green line right there is not part of the graph. That's your vertical asymptote. And your horizontal asymptote is the y-axis. It's y equals 0. So this is the parent graph that we start from when we have just a basic rational function. So let's look at what we can do to this graph to transform it. All right, so here we're asked to tell which graph shows 1 over x plus 2. So if we're looking at this, x plus 2 is not inside of parentheses, but it is in the denominator of the fraction. And we could put parentheses around that denominator of that fraction there. And that means that we're adding 2 inside of the parentheses. Whenever we do that, that's going to move the function to the left or to the right. And in this particular case, since you have a plus 2, you're going to go to the left 2. Remember, everything inside of the parentheses is in the opposite direction. So you have a plus 2, which makes you think that you should go to the right, the positive direction. However, it's actually going to go to the left. So what happens there whenever we move this graph to the left is that vertical asymptote should move to the left 2 units. So we can see that these first 2 graphs that we have here, neither one of them have been shifted left or right. So that would not be the correct answer. The correct answer is going to be the third choice right here, because we can see that we're shifted to the left 2 units. Each one of these lines is 2 units. Over here, this would be incorrect because this graph has been shifted to the right. So this would be our answer here for this problem. Okay. The next question asks us, what is the equation of the horizontal asymptote of f of x equals 1 over x minus 3 plus 7? So we've got to think of what a horizontal asymptote is first. First of all, a horizontal asymptote is always going to be a number that, always going to be an equation that is a y equals equation. It has to be a horizontal line, and horizontal lines are always y equals equations. So immediately I know that I can throw out A and C here. Those are not going to be correct answer choices because those are vertical lines right there. So that narrows it down to y equals 3 and y equals 7. And so if you're thinking of that graph, if you're thinking of that horizontal asymptote, I'm going to pull up just regular Desmos over here so that we can see it. And so if I've got f of x equals 1 over x here, if I'm going to change that horizontal asymptote, I'm going to change that horizontal asymptote by moving this graph up or down. And to do that, I would have to change, let's see, I'm going to do this right here, so we'll add a slider. I'm going to have to change this value that's added here on the end. So that will move the graph up or down, and in turn change the horizontal asymptote. So if we go back to this question here, this graph has been moved up 7 units. So where normally the horizontal asymptote would be right there at the x-axis at y equals 0, it's been moved up 7 units. So the last answer choice there, y equals 7, is going to be our answer. And we're not going to explain our mean limits. Take that off. All right, so let me just give you a little preview of what you're going to be doing on your assignment that goes with this. You're going to do a marble slide. And so the marble slide is something in Desmos where you have to move these graphs around. And then if you'll click launch over here, you'll have all these little purple balls. And your goal is to get all of those stars to go away. All right, so here's an example of one that you actually have to do. Your directions over here say change one number in the row below to fix the marble slide. So right now, if I launch and I don't change anything, I'll get most of the stars, but I don't get this one right here. So if I want to fix this this graph, it would really be helpful if this curve right here lined up a little bit further over here to the right. So if I want to move something further to the right, I need to change this value that's down here in the parentheses, because that changes something left to right. So I'm going to take that +1, and really I would like for it to be maybe -2. That's a little bit too far. So -2 would move it to the right too. That'd be a little bit too far. So maybe a 1.5, and that looks like it lines up pretty well. There's probably some other things that would work there. If I click launch now, you can see all of the stars are gone and I have a success. So that's some of what you'll be doing in the marble slide activity. Okay, next thing I want us to talk about are reflections. So the purple graph, the purple dotted graph right here, that's just f of x equals 1 over x, the parent rational function. So if we put a negative in front of that, then that is going to reflect the graph over the x-axis. However, because of the symmetry of this graph, you really can't tell whether it's been reflected over the x-axis here or whether it's been reflected over the y-axis. That's because if you put the negative in the top of the equation or the bottom of the equation or out front, it really doesn't make a difference here. So a negative is going to switch the graph from being up here in the first and third quadrant to being in the second and fourth quadrants. Okay, so here's an example where you've got to know that. So in this example, we're supposed to change one number, and I wish this would let me zoom out a little bit. It doesn't let me, I don't think. I'm gonna hit launch just to see where that purple ball is dropping from. So the purple ball is dropping from right here, and clearly that's not going to do us any good right here. So what we need is we need the purple ball to drop from right here, and we need to go this way. So if I go over here to my equation and I just put a negative right there in front of the 4, then I think that's probably going to do the trick. Notice this also. Instead of putting it in the top of the fraction there, if I put it out front, it would do the same thing. So either place is fine. And let's click launch to see if this will work. Oh yeah, I think that one's going to work nicely. And we have a success. So a reflection is a transformation that can help you on your activity here. Okay. The next thing I want us to see is there is another type of graph that we're going to see a little bit of. And the blue graph here, that is still my 1 over x. That's my parent function. But if I square this function, if I do 1 over x squared instead of 1 over x, you can see that I have a graph that looks kind of the same over here in the first quadrant, but it's been reflected over the y-axis, I'm sorry, x-axis in that second quadrant and changed a little bit there. So you'll see that whereas the blue graph there, those are going to be in the first and third quadrant, this red graph, this 1 over x squared, is going to both curve in the same direction there. So there's one other thing we need to know. Another thing that we can do is we can restrict our domain. So for example here, I have f of x equals 1 over x, just the parent function, but I have put these squiggly brackets here with the x is less than 5 right here. And you'll notice that the graph looks normal, except for it stops right here at x equals 5. So changing that number can change our domain. If I make it 6 instead, the graph will go a little bit further. If I make the if I make this 1 instead, I'll only see this little piece of the graph. I could even do something like this and say -2 is less than x less than 4, and I'll only see the graph from -2 up to 4. So we can restrict the domain here. So let's look at some more examples. All right. Here is an example where we have the x squared. Notice we got this minus 4 right here. The minus 4 causes this graph to be shifted to the right 4 units. We also have a plus 2 right here, which shifts the graph up 2 units. And we have that square that means that we're dealing with the graph turning in both directions. And then this negative is what has this graph opening down, or having the sort of like the little funnel downward. Now, if you look, if I click launch right now, all of my little purple balls are just going to drop straight down because they do not have anything underneath them. So here, if I went over here and changed my domain restriction maybe to 12 here, or I could probably go even less than that if I wanted. Now if I click launch, it's going to take it a little while. It's not very steep, but we can see that all of the stars are now gone. So, for the next thing I want us to look at is I want us to see what vertical expansions and compressions look like. I'm actually going to add to this. I'm going to do f of x equals 1 over x. So this is the parent graph. Let's change its color. Let's make it blue. All right, so that blue graph right there is the parent graph. And what I've done here is I've done f of x equals a over x. And whenever I do that, that lets this number on top change. So right now I'm looking at 0.6 over x. Well, I could move this over here, and this would be the graph of 3.3 over x. And then I could make the number even larger, and you can see I've got 5.7. So this is a vertical expansion that we're doing here, or we could think of it as a horizontal expansion, I think. Yeah. So we are seeing that this is moving upwards here. Notice if I use numbers that are smaller, I can see the graph is getting shorter there in a way. I also, if I switch over here where I have negatives, then I can see that the graph has been reflected. So this number in the numerator is going to affect the steepness of the graph here by expanding or compressing vertically. So here's a marble slide example where you might need to change something. If I click launch right now, works pretty good for the first star, but not so great for the others. So I could try to move this one up, but I'm going to have a hard time getting all of these here. So if we see here, if I move this graph up, I'm still missing this star right here. So moving it up or down is really not helping. But what I can do is I can change the number 4 right here. And if I make 4 larger, like 5 or 6 or 10, you can see it starts to change its curve to where it's a little more gradual right here. And I don't think that'll be quite enough. Let's say maybe 12. Maybe that'll work. Nope, not enough. Let's try 14. This has to work, I'm pretty sure. Okay, and there we go for that. So you can change that number in the numerator to expand vertically, and that will change the shape of your graph as well. Okay, so some of the questions that you're going to get are going to look like this. If we change the 5 to a 10 in the equation, what would happen to the graph? And so right here, we've got the equation for us, and we're wanting to know what would happen if we change the 5 to a 10. So right now, you can see that our domain restriction ends right here at 5, so we're only using the values less than 5 for our x values. So if we change that 5 to a 10, we could say maybe that the graph will extend out further here. And you can click share with class and you'll be able to see the other students' responses as you work on this. And then it's going to ask you to verify. So if you verify, if you change that to a 10, you can see that the graph extends out further. We can even move this and see it stops right there at 10. Okay, here's another one. It says if we change the 4 to a 1 in the equation, what would happen to the graph? So right now, this is a rational equation that has been moved up 4 because we can see the plus 4. We can also tell right here, this is going up by 2's here. So we have that horizontal asymptote at 4. So if we change 4 to 1, then the graph is going to have a horizontal asymptote at 1. So that would be 3 lower than it was before. So we could say the graph will shift down 3 units. So notice I didn't say that the graph would be up 1 unit because we're talking about this as our function. The graph is going to be shifted down 3. So right now it has a horizontal asymptote at 4. It's going to move down to 1, so that's down 3 units. Okay, so at the end of your assignment, this is what you're going to do. You are going to have several challenges. And for these challenges, you have to create your rational function from the beginning. So you can start just with f of x equals 1 over x like this. But as you can see, that is not going to work if I use it like it is. So this particular one, I know I need to move that graph up. So if I put maybe a plus 6 on the end, that's a little too much. Maybe a plus 5. This might work. So I could click launch and see if it'll work. It almost works, but I'm missing this one graph, this one star right here. I might could move this to the left just a little, like maybe to the right, just a little minus 0.5, and it might work. Still missing this star right here. So probably what's the better idea is if this was just curved a little bit. You can see this is a lot steeper than our stars over here. So maybe changing my 1 to a 2 or a 3 will give me a better curve, and I think this right here is going to work for us. So you're just going to play around with these a little bit and try to get these to fit. Now this next one, is really challenging. I'm not going to tell you how to do this one. It took me a little while to figure this one out. But you're going to set up, obviously if I do y equals 1 over x, that is not going to work at all. So you can play around with it a little bit, see if you can get it to work. And there's several different ones here. This one is going to be really strange because you've got these on either side. Chances are that you're going to need to use, instead of using 1 over x, use 1 over x squared. And you would be able to get this to do something like that. You also can use more than one equation if you want. So for example, let's say, I'm just going to mess with this one a little bit. Let's put a minus 1 right there. And you can restrict your domains. So maybe I would have x is less than 1, no, less than -1, no, negative 0.99, negative 0.1, 0.3, 0.5, maybe 0.5. And or x is greater than, I don't know if that works. Might have to do these separately. So I'm going to use this here. I'm going to use this one. I'm going to use a greater than positive 0.5. So I've got, notice I had to do that in 2 sets because I did not include this part right here. So now I've got something, even though if I hit launch, Still not going to work. So I could add in something different, such as y equals absolute value of x. ABS is absolute value, and if I put a negative in front of that and move it up 3.5, and then I can restrict the domain from negative 0.5 less than x less than 0.5. So this puts like a little hat right here. Let's see if this will work. Oh, it only goes one way.
That looks really cool.
Gonna work.